the macromolecules chapter, we have to talk about some basic carbon compounds, because carbon and its compounds make up all of the organic molecules that we're going to talk about, those macromolecules. So you will need to know the structure and the function of these four macromolecules, or biomolecules, as you'll sometimes see them called: proteins, lipids, carbohydrates, and nucleic acids. Organic versus inorganic. Organic molecules contain carbon, inorganic molecules do not, with a few exceptions. Carbon atoms can form several different structures. They can form long chains. These will be found in lipids. They can form branched chains, which will be found in all sorts of macromolecules. And then the carbon ring, and this one is pretty essential to living things. The carbon ring will often be drawn like this, as a simplified either hexagon or pentagon, depending on how many carbon molecules or how many sides the ring has. Now, added to these carbon molecules, either the carbon chain or the carbon ring, will be functional groups. And functional groups are a collection or group of atoms, and these atoms are going to influence the characteristics of the molecules, and they also affect the chemical reactions that the molecules undergo. Some examples of functional groups are hydroxyl groups, carboxyl groups, amino groups, and phosphate groups. There's a table on page 52 in your book that'll give you a little bit more information about these. But amino groups are an important part of amino acids, which make up proteins. That's one of the macromolecules. The phosphate groups are an important part of several of the macromolecules. So hydroxyl groups, and we'll just click through these. You don't have to know this, but if you're interested, there you go. Here's the chart from your book. So a hydroxyl group, here's a chain of carbons. Even though it's just two, it's still a chain, and we've got a hydroxyl group on it. A carboxyl group is a carbon along with an OH and a double bonded oxygen. And here it's attached to a carbon molecule. And here's an amino group, and an amino group is made of nitrogen and hydrogens. And then you have a phosphate group, which is made of phosphates, hydroxyl groups, and oxygens. So macromolecules. Macro means large, right? And these large molecules are made of many monomers. Now, this is important vocabulary, because this is what you'll see most likely on the EOC. So many monomers all linked together make a polymer. So there are monomers. These happen to be carbon rings. If you link them together, see our little plus sign, we link them together and you get a polymer, many mers. And they're linked, and this is considered a polymer. If you think of a pearl necklace, each individual pearl would be called a monomer, and the whole strand of pearls together would be a polymer. So, polymer, there it is, polymerization. So, we are going to link these monomers together, and that's what polymerization is, linking monomers together. It's called a condensation reaction because a water molecule is released. Now, when you think of condensation on the outside of a sweet tea glass, or condensation when you breathe on the mirror, or when you take a shower and there's condensation on the mirror, it's water, right? It's water that has come out of the atmosphere. So in a condensation reaction, you have water that is released from the reaction. And a polymerization, linking these monomers together, releases a water molecule. So in the picture here are my monomers. I have 3 of them. And I have a plus sign between them because we're going to link them together. And then when we link them, and they're now joined with a straight line, we have 2 water molecules that get released. 1 per linkage. So there's 1 link here and 1 link here. So we had 2 links created, and there are 2 water molecules. Now, not to blow your mind, but if you were to look at these carbon rings with all of their carbons and other groups, here's where the water comes from. When you link a glucose and a fructose together, you have this hydroxyl group and this one, and here's our H2, so there's our 2 hydrogens, and our oxygen, H2O. There's 1. And then these molecules actually share this oxygen molecule because this one was released with the 2 hydrogens. So now these 2 carbons are going to share this oxygen molecule. So what happens when you break polymers apart? It's called a hydrolysis reaction. Hydro meaning water. And this right here means to put it together, so it requires water back in order to break these apart. So a hydrolysis reaction breaks a monomer and uses a water molecule in the process. It's kind of the reverse of the condensation reaction. And this often requires an enzyme. Remember, our ASE means enzyme, so sucrase. The first part of the name comes from sucrose, which is the name of this polymer. So sucrase is going to break this polymer apart. So the enzyme, sucrose, and water all together will give you, after the reaction, there will be a glucose and a fructose molecule. So the main points here are that carbon molecules are unique because they can bond in a variety of shapes. The functional groups change the characteristics of these molecules. And macromolecules are simply long strings of monomers that can be added and removed.